someone that makes me feel seasick. Oh, what a skill to have. Oh, what a skill to have so many skills that make her distinctive. They're not mine.
Okay, number 2 asks us to solve for all solutions on the interval 0 to 2 pi. Okay, so we have this equation here, and we see automatically that we have some kind of double angle going on. So that means we're going to need a double angle identity for this. So on this one, I'm going to use the cosine squared theta minus sine squared theta 1, that version there, because we see that on the right-hand side we have this 9 times cosine squared theta, which, when we distribute that 9 in, we'll see that exact same thing occur on the left side as well, right? So we obtain something like this, where we have 9 times cosine squared theta on both sides. So that means we can subtract that away. So those guys just go away, which is really nice. And then let's say we add this 9 sine squared theta to both sides, plus 9 sine squared theta. So this becomes 0, and we get 9 sine squared theta minus 4 is equal to 0. Right? And here we actually see that this is a difference of 2 squares, so we could factor this out into 3 sine theta minus a 2 times 3 sine theta, and then plus a 2, okay? And then this is equal to 0. Alrighty, so let's continue solving this on the next slide. So we got 3 sine theta minus 2 times 3 sine theta, and then plus 2 is equal to 0. Okay, so to solve each of these, we get sine theta is equal to 2 over 3, or sine theta is equal to negative 2 over 3. So because these are unfamiliar values, we'll need to break out that inverse sign, right? So if we inverse sign both sides, we get theta is equal to sine inverse, or inverse sine, of 2 over 3, and it could also be sine inverse of negative 2 over 3. So let's see what answers we get for this. And again, we're looking for answers on 0 to 2 pi, aka from 0 to 6.28. 6.28, okay? So when we plug these into a calculator, we're basically just going to get the values of 0.7297, and for this one we'll get an answer of 3.871. So the thing is, these actually happen at 2 points on the unit circle, so let's do this first one. So sine is equal to 2 over 3, so we got an answer like this, somewhere in there. So there's another one that occurs at this angle here. But we didn't find that one because the calculator only gives us one value, so it gave us this theta here. So because of the unit circle being symmetric, we have the theta over here, so all we have to do is subtract that away from pi. So we get pi minus 7297. So that one's going to actually come out to be 2.4119. So this is another answer we could get. So this is an answer, this is an answer, and that's an answer. And we also get this other one. So 3.871, that's somewhere around here, right? Because this is 3.14. So we got one here, and then we should also get another one over here. And we're going to obtain that answer by taking the difference between here and here. So this would give us kind of like the reference angle created by there, and then we'll just subtract it away from 2 pi in order to get this entire angle. Okay, so we're going to take this 3.871. We're going to do 3.871 minus pi in order to get this tiny little angle in there. And that tiny little angle is going to be the same as this, which we're going to subtract away from the whole pi. Or, sorry, that's a bad choice of words. From the whole pizza, from the whole circle, in order to get that entire angle. So we're going to take this guy and then subtract that away. So we'll do 2 pi minus this, okay? And then when we do that, we're just going to get an answer of 5.554, okay? And that is our fourth angle there.
Bridges.